Hello, my name is Christopher Pratt, and I'm from the University of Utah Robotics Center. The focus of this work was combining a flying platform with passive dynamic walking legs to create a robot which can both walk and fly. So, the robot is a quadcopter platform with attached passive dynamic walking legs. For those unfamiliar with the field of passive dynamic walkers, they're motorless mechanisms which can walk down a slope without being powered. We chose to use passive dynamic legs because they offer a low energy form of ground locomotion, which doesn't add any additional actuators to the system. So our robot has three forms of locomotion. It can fly using the quadcopter platform, it can perform a no power walk down a slope, and can also perform thruster assisted walking along flat or inclined slopes. So the contributions of this work include the modeling, design, and prototyping of the robot. During the modeling process, we obtained the equations of motion for both the lateral and sagittal directions, which incorporates the dynamics of the flying platform, as well as the friction from both the bearings and the feet-to-surface interactions. Then we used the model to guide the design of the feet and the legs of the passive dynamic walker. For example, shown in the top middle plot is a simulated phase portrait of the walker entering a stable limit cycle that we used to analyze the robot's walking stability. Afterwards, we used the parameters from the model to develop the prototype robot shown in the bottom right figure. Additionally, we developed a model to analyze the energy consumption between thruster-assisted walking versus flying. We found that given the same amount of energy, thruster-assisted walking can theoretically travel a similar distance to that of flying, although at slower speeds. Finally, we used the prototype robot in a physical experiment to validate the dynamics model, with comparable results between the experiment and the model. So shown here is a video demonstrating the three forms of locomotion. We first have the robot flying onto the platform, and then after a small push from the thrusters are turned off, and the robot enters a no-powered walk down the slope using its passive dynamic walking legs. And then, once the robot reaches the bottom of the slope, the thrusters are turned back on and used to perform thruster-assisted walking up the slope. During the thruster-assisted walking, only the rear thrusters are used to both pitch the robot forward and rock it side to side. And then, once the robot reaches the top of the slope, it flies away. So thank you for listening, and come to the interactive session if you want to learn more.